This is question 2 of the P1.4 end of topic test. Question 2 has a part A, a part B and a part C section. Unfortunately, not all of it will fit on the screen at once, so at the moment I'm displaying the part A mark scheme. So please mark part A. You may wish to pause the recording now so you can do that. Once you've finished marking part A, please restart the recording so you can move on to part B. On screen now is part B of the question, so please pause the video so you can mark part B. Remember to restart it to mark part C. On screen now is the final part of question 2, which is part C. You may wish to mark your work using this part of the video. If you get all of your work correct, I suggest you move on to the next question. If you get parts of the question incorrect, that's including part A and part B, please listen to the rest of the recording to find out how to answer this question correctly in the future. You may wish to pause the recording now so you can mark part C. In part A, you're given a Sankey diagram that shows the energy transformations in a fuel burning power station. You can see that you're giving out electrical energy and also heat energy. It says name one fuel is burned to provide energy, the energy source for a power station. So basically you can have any of the fossil fuels, which are coal, oil or gas. You could also have biofuels, and any of the fuels on screen now will get you 1 mark. There's only a maximum of 1 mark, so you just need any one of those. Now when we come to answer part 2 of A, it says to use the diagram on the equation in the box to calculate the efficiency of the power station. So, because this is quite awkward to do, I've gone through the process of writing things on the board first, so I'll draw your attention to the bits that I've done. So when you use this equation, this one here, actually says that efficiency is useful energy transferred by the device over total energy supplied to the device. So we know that useful energy for an electrical power station is to produce electricity, which is this bit here. Now what I've done with my calculations when I'm working out, that you can see over here, is that I've drawn a line across the Sankey diagram, okay, which you should remember from P1.2 and 1.3. And I've then counted the number of squares. And if you count across, you've got 1, 2, 3, 4, 5, 6 squares, which I've written here. So my useful output energy is 6 squares. I need to look at my input energy, which is over this side of the board. Okay, and again, I've drawn these down. And if you count the squares, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 14, 15, 16, 17, 18, 19, 20. Okay, again, it's very difficult to point on an iPad. So I've got 20 squares as my input. So using this equation, useful energy transferred by the device is 6. Total energy supplied to the device is 20. 60 divided by 20 gives you 0.3. And that will get you 2 marks. 1 mark for that bit there, 1 mark for that bit there. Now you may have used the equation for efficiency that we learnt in P1.3, which is basically times by 100. If you've done that, you'd have worked out 30%. Again, you get both marks for that. Let's move on to the next part of the question. In this part of the question, you're asked to name the process by which a nuclear fuel provides the energy needed to generate electricity in a nuclear power station. That's just a quick recall of the definition, which is nuclear fission. In this case, the bit that you get the mark for is fission. There's 1 mark for getting nuclear fission there. In part B of the question, you're asked to describe what is meant by a device being efficient. So if you're an efficient device, you waste little, small amounts of energy. That again is something you should know from P 1.2 or 1.3, is the idea that it wastes little amounts of energy. You can also have the reverse argument, which is that most energy is transferred usefully. And it's a mark for either one of those, but remember, you've only got a maximum of 1 mark. In this question, you're asked to explain how a national grid system reduces the amount of energy lost as heat. In order to do that, you need to remember that you're basically talking about a step-up transformer. So use a step-up transformer. And if you can remember what a transformer does, you basically increase potential difference or voltage, which decreases current. That bit, any of that bit there, so the idea that you're either doing any of this bit here is worth 1 mark. It's only 1 mark for both of us. You could have increase PD, 1 mark, decrease current, 1 mark. And the idea is doing a step-up transformer is not necessarily required. The next mark is that the idea that the lower current, the less energy is wasted as heat. And with that, what you're looking at for getting the mark there, that's the second mark. The idea you got a low current, less heat is wasted. That's the mark. So just to run through the marking criteria for that again, you mark for basically saying it either increases PD, that could be a mark, or you said decrease current, that could be a mark. But you don't get 2 marks for saying that statement. The next mark is for saying the idea that the lower current, the less heat is wasted, or the less energy is wasted as heat. And that's how you make the national grid more efficient. Part C of the question, you're asked to read this information taken from a recent newspaper article. Just to read this through, because I think sometimes lots of students don't read things through correctly, which is what costs them marks later on, because most of the answers will be hidden inside this text. So basically, researchers have found that children living close to overhead power cables are more likely to develop leukemia. The researchers studied 2 groups of children. One group had developed leukemia, the other group was healthy. Although the researchers found a link, they are unable to explain why it happened. They say that the results may have happened by chance. Other factors that have not been investigated, such as the environment, the geographical area, or the children's genes, could also be important. And finally, a cancer research charity said that childhood leukemia was most likely to be caused by factors that parents were unable to control. So the first part of question C says, why did the researchers study a group of healthy children? Now this is a question that comes up on most physics papers, or most science papers at least once. I imagine that during your time doing your GCSEs, you will have to answer a question very similar to this. So why is it you use a healthy group of children as a control? Okay, the key word you're looking for there is a control. If you get the idea across that you need to make a comparison, you can also have the mark. But the main one, the key word to learn is that it's a control. Moving on to the next question, it says that the information does not say how many children were studied. Why should this data be included in the article? Well, the reason it should be included is so that people could make a judgment. So the reader can make a judgment about significance. Okay, keyword judgment. Okay, obviously you know that if you use a large number of pupils or students, it's more likely to be correct. And any idea that a larger number will be better. But the key thing that you're trying to get across there is the word judgment. So they can judge it, they can assess it, they can form an opinion, they know how many numbers is based on. So the judgment's the key word. This next one says the researchers could not be certain that the overhead power cables were responsible for the increased chance of children developing leukemia. So explain why. I'll just drag this bit out here because that was from the text that we read through. And the reason why is that other factors could be to blame. That gets you 1 mark for that bit there. And the next mark is for naming a factor. And just to highlight them, so you could have an environment, the geographical area, or children's genes. And any of those 3 will get you the 3rd mark. So you get a mark for any of those 3 being written down here. And the final part of question 2, you're given the idea that the results of the research carried out by scientists may worry some people. What do you think scientists should do? Please put a tick in the box next to your choice. And the idea is that scientists should publish their research findings straight away, or that scientists should not publish their research findings until they have found out as many facts as possible. Now, there's no right answer for this. You could have either box as long as you've justified your choice. So if I tick the first box, saying that they should publish it straight away, is so that you can write down a reason why, which is that so people are aware there may be a risk. The other reason they could do it is so that other scientists could check their work, or other researchers would know about it so they could research their work. So that would be the first one. If you tick the second box, which is scientists should not publish their research findings until they have found out as many facts as possible, the main reason they don't want to do that is you don't want to worry people. And that's so they don't cause people to worry. The last thing you want is everyone panicking and moving away from overhead cables and moving houses when actually there's no reason for them to do that. So in this case, what you need is not a mark for getting the box ticked correctly, it's a mark for ticking the correct box with the right reasoning. And that brings us to the end of question 2.